All right, class, welcome to section 7.2, where we'll continue our discussion on conic sections. Ellipses are next. An ellipse is really just an elongated circle, kind of like a rectangle is an elongated square, right? So the definition of an ellipse is that it's the collection of all points such that the sum of their distances to two fixed points is constant. So what this means, first of all, these two fixed points that we're starting with this time are called the foci, which is really the plural of a focus. So here in this picture, as you see, there's quite a lot going on in an ellipse. Here is one focus, and here is another focus. Again, plural of it is foci. So these points on the blue shape, which is the ellipse, have the property that if you measure their distances to these two foci and you add them together, or you move on somewhere else, measure the distances, add them together, the sum of these distances to the two foci are always the same number. So the sum of the distances from any point on the ellipse to these 2 points is constant. Best way to draw an ellipse is to start with 2 pins, so pin them somewhere, draw or tie a loose string on it, and then take your pen and then push out until this string is spanned out, and then take that pen and go all around, and then you will draw an ellipse. Okay, so the sum of the distances, which is that string I'm telling you about, is constant. Okay, so let's look at some of the features of an ellipse. Now, halfway between these two foci that we're starting with, the point halfway through is called the center. So an ellipse also has a center. This, as you see, has a longer side and a shorter side. The longer side is called the major axis. The shorter side is called the minor axis. At the end of the major axis, so at the end of the longer side, you have your vertices. Vertex is one. Vertices is the plural of a vertex. And at the end of the shorter side, you have your co-vertices. Okay, and there it is. So we're going to try and formalize these equations by placing an xy coordinate system on top of an ellipse. And again, at first, we're going to keep the center of the ellipse in the center of the xy plane. And then I have a few labels for you. The distance all the way from the center to the vertex is called A. And again, the ellipses can be elongated along the x-axis, or they could have their longer side along the y-axis. In other words, the major axis could be on the y-axis, or the major axis can be on the x-axis. Either way, the distance from the center to the vertex is A. The distance from the center to the co-vertex is B, so the shorter side is B. Okay, and so let me write immediately the equations for you. X squared, as you see in this picture here, A is in an x direction and B is in a y direction. So whatever's under x squared go, again, the distance in an x direction is going to go under x. The distance in the y direction is going to go under y. So as I said, sometimes this longer side could be in the y direction, as in this picture. So then the a squared goes under y. And then the b squared will go under x because that's what goes in an x direction. Okay. So again, the longer or the bigger of those two numbers is going to be the distance, of course, from the center to the vertex, which the vertex is at the end of the longer side. Now there's an equation that's also putting the vertex, co-vertex, and the focus together. So here are the two foci, and the foci are always on the major axis on the longer one. Now the distance between the center and the focus is labeled by C, as you see also from the coordinates of these points. So the equation that puts A, B, and C together is very similar to the Pythagoras theorem, but I want you to be mindful of, again, it's not always A squared plus B squared is C squared. It depends what A, B, and C are labeling, right? In a right triangle, A and B are the shorter sides, and C is the hypotenuse, so therefore A squared plus B squared will equal to C squared, because C is the longer side, so that's why it's by itself. When you look at the ellipse, the longer side, or the bigger number, always is going to be A. As you see, A is always more than B because it's the longer side, and A goes past C because the vertex goes past the focus. So therefore, A will be by itself, and the B squared and the C squared are going to have to be added together. So we'll use this equation in the future examples. So I just want to knock the formulas out of the way. Of course, if we do take the ellipse off the origin of the xy plane, so if the center is not at 0, 0, but it has some coordinates hk, just as in the situation of the circle that you've seen in 7.1, what we're going to do is subtract this h and this k from x and y. In the same way, it doesn't matter whether the ellipse is horizontal or vertical. The x coordinate of the vertex gets subtracted from x. The y coordinate of the vertex gets subtracted from y. Okay. All right, so let's really look a little bit, and let's get more familiar a little bit more with the ellipse. So here's the picture of an ellipse. What we want to do first is identify the vertices, co-vertices, and the foci on the graph. So I'm going to add on as well the center. So the center, first of all, as that's where we'll start, as you see, is at 0, 0 in the origin. Now the vertices are the points at the longer ends of the ellipse. So if I zoom in, that's going to be 9, 0, and negative 9, 0. Now you could very well write this as plus minus 9, 0. So you can write it combined, and then we'll know it means positive 9 and 0 and negative 9 and 0. So two different points. So it's up to you. In other words, you can write them separately or you can write them combined. The co-vertices are the points on the shorter ends. So let me write it out. As you see, these are points on the y-axis, so therefore the x-coordinates are 0. And as I zoom in, I see it's a 4, so plus minus 4 for y. Okay, so be very careful and mindful whether or not your points are on the x-axis or on the y-axis, right? Then it depends on who's going to be 0. And finally, I see the foci bubbled in here, and I see their points are labeled. So I see the foci have coordinates plus and minus the square root of 65 and 0. Okay. So I want you to also verify the equation I gave you earlier. For our ellipse right here, A, again, is the distance from the center all the way to the vertex, so that's 9 units. B is the distance from the center all the way to the co-vertex, and that's 4 units. And C is the distance from the center all the way to just the focus, and according to the labeled point, that's a square root of 25. So I want you to verify that indeed a squared will equal to b squared plus c squared. So a squared is 9 squared, b squared is 4 squared, and c squared is the square root of 65 being squared. So once you square these numbers, you'll get 81 is equal to 16 plus 65. Is that a true statement? Yes, it is. 16 plus 65 is 75, 81. So that's correct. All right, so let's see if we can graph these ellipses. It actually is super easy. So let me show you how this works. To graph this ellipse, number one, same as with the circle, we want to identify where the center is. Plus, it also says find the coordinates of the center, vertices, co-vertices, and foci. So we have to give all these coordinates. I'm going to start with the center. So I'm looking, is something subtracted from x or y? No. So therefore, the center is going to be at 0, 0. That's where I start my counting. Now, all you have to do is look what is under x. Okay, so what's under x is a 9, and 9 stands in for 3 squared. So therefore, in an x direction, I'm going to go 3 units to the right and 3 units to the left of the center. Under y squared, I see a 16. So 16 stands in for 4 squared, or in other words, the square root of 16 is is 4, right? So I'm going to, in a y direction, go 4 units up and 4 units down, and here is my ellipse. Ta-da, done. Okay. So it says, give me the coordinates of the vertices. The vertices are at the longer end. So therefore 0 plus minus 4. The co-vertices are at the shorter end. So therefore plus minus 3 and 0. Wait. So we got them when 3 units right and left. So again, vertices is what's on the longer end, and co-vertices is what's on the shorter end. Now to find the foci have to be somewhere on the major axes. Okay. To find the foci, we have to use that equation that said that a squared is equal to b squared plus c squared, and we have to find that c distance. Okay, that's too many c's. So I'll do that. Okay, so a squared is 16, b squared is 9, and the way I know this is, again, right here under x squared and y squared are a squared and b squared. A is always the bigger number, so a squared therefore is 16, and b squared is 9. So when I minus the 9 over, I get 7. And then I'm going to take the square root on both sides. So c is plus minus the square root of 7. So in other words, the distance from the center to the focus is a square root of 7. So one's going to be at 0 square root of 7. And the other one's going to be down at 0 negative square root of 7. All right, and this is it. So we'll try another one. Now, for all these ellipses to match up and understand how to move and where everything is, the equations have to equal to 1. Okay? And usually you have fractions, and that's not what we have. So we will take a first step to have it equal to 1. We're going to divide everything by 16. And of course I can reduce these fractions even more. 4 and 16 reduce and leave you with a 4 at the bottom. 16 and 16 reduce and leave you with a 1 at the bottom. So there you have it. Okay. All right, so let's start this again. The center is in the origin because, again, I see nothing subtracted from x and y. Under x squared, or under the x, I see a 4, and 4 is the square of 2. So in an x direction, we're just going to go 2 units left and 2 units right. Under y, I see a 1, and the square root of 1 is 1, or in other words, 1 is 1 squared. So in a y direction, we'll just go 1 unit up and 1 unit down. And here's our tiny little ellipse. So again, the vertices are at the end of the longer side. The co-vertices are at the ends of the shorter side. So they're on the y-axis, therefore x is 0 and y is 1 or -1. And to find the foci, somewhere here on the major axis. So again, the foci are going to have a y-coordinate of 0 since they have to be on the x-axis. And that's where the major axis is. And to find them, I'm just going to solve this equation. A squared is equal to b squared plus c squared. A squared is 4, b squared is 1. Again, the bigger number of these two always stands for the a squared. So from here, I can easily solve, and c squared is going to be 3, which means c is plus minus square root of 3. So to get to the focus, I have to go square root of 3 units to the right of 0 and square root of 3 units to the left of 0 to find them. All right. So here are a couple more. We'll start with the center, and as you see, this time we're not in the origin anymore with our center, but the center is going to be at -1, +3. Again, -1 because that's the solution to this factor equaling to 0, and +3, that's the solution to this factor equal to 0. So you just have to switch the signs on those two numbers. That again, what's being subtracted from x and what's being subtracted from y. So we're starting our ellipse at -1, +3. Okay, and then the number of units we're counting depends on the numbers underneath. So under x, I see a 25, which is the square of 5. So I have to count 5 units left and 5 units right. Under the y, I see a 9, which stands for 3 squared. So I'm going to go 3 units down and 3 units up. And here it is, the ellipse, just as easy. Okay. Now, if you draw a really pretty picture, you do not even have to use any formulas. We don't use really formulas right here. We just look at it. So from -1, we added 5, by the way, and we got to 4. You could also see 4, 3 is the coordinate of one vertex. And then as you see, -6 3 is the coordinate of the other vertex, because again, we started at -1 and subtracted 5. For the co-vertices, 1 is here at the top. X coordinate is -1, Y coordinate is 6. And you could see it. And the other co-vertex, again, the X coordinate is -1. The Y coordinate, as you see, is 0. And that's because, again, we started at 3, and we added 3, and then minus 3 from 3. Okay. And finally, to find the foci, which, by the way, the foci are going to have to be somewhere here on the major axes, I have to find that C distance from the center to the focus. Okay, so A squared is B squared plus C squared. A squared is 25, B squared is 9, and then we're going to find C squared. So when I minus 9 from 25, I'll get 16. Taking the square root of 16, I'll get 4. So in other words, to find the focus, 1, 2, 3, 4, and 1, 2, 3, 4 units left and 4 units right, are the two foci. So here it is. One of them is going to be at 3, 3. X is 3, Y is 3. And the other one is going to be at X is 3. And I'm sorry, X is -5. And Y is 3. So you could tell that simply by counting and just by looking at the pretty graph we drew. All right. So one more practice again. Very much encourage you to stop the video and try yourselves. So the X coordinate of the center is 1. The Y coordinate of the center is -2. And here it is. Under the X, I see 4, and 4 is the square of 2. So we're going to go 2 units left and 2 units right from the center in the X direction. Under the Y, I see a 16, and that's 4 squared. So I'll go 4 units up and 4 units down in a Y direction. So again, this is a vertical ellipse. The vertices are at the top and bottom. So one of them is going to be at 1, 2. And the other one is going to be at 1, -6. And again, you could see that all the x's are 1 on this line. And from -2, we added 2. And from -2, we subtracted 2. The co-vertices are left and right. So at 3, -2, and at -1, -2, again, they're in the same horizontal line with the center. And then from 1, we added 2 and we minus 2. So that's why we got to 3 and -1. All right. So here it is, and now the foci. Again, A squared is B squared plus C squared. A squared is 16 is the bigger number right here. B squared is 4, so therefore C squared is going to be 12, or C is going to be the square root of 12. So to find the foci, we have to go up and down from the center by a square root of 12. So as you see, the X coordinates are still going to be 1. Yes, we are on this vertical line where all the X's are 1. And then from the center, which is down at -2, we have to add square root of 12. And then we have to subtract square root of 12. And that's how we'll get to those foci. So this time the foci are not plus minus square root of 12 because we didn't start at 0, right? The center was not at 0, so we started at -2. That's where we added square root of 12 and minus square root of 12. Now in a test, I would not I would make you graph an ellipse, but I would not really make you list the coordinates of the focus for a problem like this because it is a little bit tricky. I'm trying to keep it, as always, as simple as possible. So now let's just go backwards, and this is it. So we want to find the equation of the ellipse with center at 0, 0, one focus at 4, 0, and a point on the graph at 0, 3. Now, even though none of these problems will say for you to graph, you really cannot come up with the answers unless you help yourselves with a little picture. Okay, so we know the center is in the origin. We know one focus is at 4, 0. Therefore, the other focus is going to be at -4, 0. That's just the foci. There's a point on the graph at 0, 3. Okay, so therefore, remember, the ellipse wraps itself around the foci. It doesn't turn at the foci. It turns at the vertex. The foci are inside the shape. Yes, here it is. The foci are inside the shape. Okay. The ellipse turns at the vertex, so we have to go past this 4 somewhere. Okay, so let's start writing this equation. All right. Now, first things first, I see that I don't have to subtract anything from x or y because the center is at 0, 0. Okay. And then to figure out what we put under x, we have to figure out what's the distance from C to the vertex. And to figure out what we put under y is find the distance from the center to this co-vertex. Well, that's easy because that was given to us. So that's 3 units, so 3 squared. And so to find a squared, I have to simply use the equation we've been using that puts the vertices, co-vertices, and the foci together. So a squared is the one that actually we have to find. B squared is this 3 squared that we have. C is the distance from the center to the focus, and that's 4 units. So there you have it. So a squared has to be 9 plus 16, which is 25. And of course, we already know that 3 squared is going to be 9. And there it is. So let's try this again. Find the equation of an ellipse. This one's even easier. With vertices at 0, 5 and 0, -5. So these are the vertices. Therefore, the center is smack halfway between the vertices. So therefore, it's 0, 0. The co-vertices are at 3, 0 and -3, 0. So that's it. That's really all I need. So x squared over plus y squared over equals to 1. Don't forget the equals 1. And there it is. In an x direction, to go from the center to the end, that's 3 units. So when you square that, you get 9. In a y direction, from the center, as you see, to the edge, which is the vertex in this case, is 5 units. So 5 squared is 25. And that's that. So here's another one that gives you the foci and the vertices this time. And so let's find this one more time, just like the first problem we did. The foci are at 5, 0 and -5, 0. the vertices are 8, 0, and negative 8, 0. So again, therefore the center has to be smack halfway through the middle. And then the ellipse has to be pictured this way. So let's write the equation. Again, luckily, the center's in the origin, as we see, so there's nothing to subtract from x or y. And so the distance in an x direction from the center all the way to the vertex is 8 units, so therefore an 8 squared will go under x. And we just need to find what's b squared, right? So what's the distance from the center to the co-vertex? Okay, so we know that a squared is b squared plus c squared. A squared is 8 squared, so 64. C is the distance from the center to the focus, which is 5. So 5 squared is 25. So b squared, I believe, is 39. Yeah. So that's what goes right here. And 8 squared is 64. So you have x squared over a squared plus y squared over b squared equals to 1. Right, this one's pretty easy and very straightforward. To find the equation, I see it's an ellipse, so the first thing I'd want to identify is where is the center. So I go from longest side to longest side. Whoops. And then same thing here. So I see that center is at an x of negative 2 and a y of positive 2. Yes. Okay. And that's it. So from x, I have to subtract the negative 2. From a y, I have to subtract the positive 2. And then I just have to count how many units in an x direction, how many units in a y direction are we moving. So that's just 2 units. So 2 squared is 4 to go again from the center to the edge of the ellipse in an x direction. And in a y direction, that's 3 units, and 3 squared is a 9. So you see 3 units up, 3 units down, 2 units left, and 2 units to the right. All right. This is a good story too. It says a bridge is to be built in the shape of a semi-elliptical arch. So by a semi-elliptical arch, semi means half, so we're going to draw half of an ellipse. And the span of this arch or of this bridge should be 120 feet. We know the height of the arch at a distance of 40 feet from the center is to be 8 feet. And we want to find the height of the arch at its center. So let's identify where the center is. So the center is going to be halfway. And the best way to solve this problem is to place an XY plane, and easiest thing to do is again to place the center in the origin of the XY plane. Therefore, we can try and come up with the equation of this ellipse based on that. And let's see what we know. We know the span of the whole bridge is 120 feet. So from here to here is 120 feet. There from the center to one of them is only 60 feet. So in other words, A is 60. And to find the height of this bridge at the center really means to find the B value that's going to go under here. So That's really what we need to find. Okay. Now we are given one extra information. It says if you are 40 feet from the center, the height is 8 feet. So in other words, the point of coordinates 40 for x and 8 for y satisfy this equation. So that's how we'll get to B. Okay, so that's 1600 over 3600 plus 64 over b squared is equal to 1. I'm going to minus the 1600 divided by 3600 from both sides. And so I'll get 5 over 9. Great number. All right, and we've solved rational equations back in chapter 5. So in other words, we don't want these fractions. There's two ways of solving this. You can, at this point, cross multiply, which basically is the same thing as you multiplying by a 9 and a b squared on both sides, because you want to get rid of 9 and you want to get rid of b squared. So there you have it. So let's see, 64 times 9 and then eventually divided by 5, I'll save some time, is 115.2 for b squared. So of course I'm also dividing by 5 both sides. And then to find that b value, I'm taking the square root. So I don't want to keep going down, but the square root of this number, excuse me, is 10.73. So this is how tall the bridge should be at the center. 10.73 about units. And there was a nice application of ellipses.